Hello and welcome to M0DCV Shack in Foxton. We're making a short video to cover some of the practicals that you're obviously not going to be doing by going down the remote invigilation route. And what Brian, M0IPO and I hope we're going to achieve is to make the theory a bit more accessible by showing you how the practical aspects of operating a radio links in with some of the theory that we're going to be telling you about in the Zoom sessions. On the CDART website there is already a video which shows you the main parts of the station and how to connect up the radio, the power supply and the antenna matching unit. Please make sure you have watched that video before watching this video any further, because that video that's on the website is really important to help you understand what's going to happen next. The first thing we're going to do is to match the antenna to the frequency that we're going to operate on, and so that we are going to remove the reactive part of the antenna load from the load that the transmitter sees. So the transmitter really only wants to work into a load of 50 ohms resistive, but as you will have seen from some of the theory sessions, the antenna is very rarely 50 ohms resistive, only at one frequency, and it's largely a complex impedance of either being inductive or capacitive, and the antenna matching unit is the device that takes out that reactive part so that the transmitter just sees 50 ohms. Now, normally what you do when you're operating your own station is that you will have written down all the settings of the antenna matching unit for the various frequencies that you operate on. But for the first time, you've got to find where these settings are. And you do that by turning up the volume and moving these controls to find where you're getting the maximum noise. Once you've found that position, you can then fine adjust these controls to make sure that when you operate the transmitter, the reflected power back from the antenna that the transmitter sees is zero, or as near to zero as you can get it. Okay, so we found the point, the settings, the rough settings on the antenna matching unit where we have maximum noise coming from the receiver when we've chosen a clear frequency. Be very sure you do this on a clear frequency rather than one that's being used. So my clear frequency is 3.74 megahertz in the 80 meter band, and I've put the transmitter into the AM mode, amplitude modulation, so that when I press the push to talk, I will generate a carrier wave. I've turned the radio frequency power right down as low as it goes, because you don't want to load the transmitter when it's running at high power when you haven't got the right setting. So over here on the antenna matching unit, I have the 2-needle display. This scale shows me my forward power, and this scale shows me the reflected power coming back from the antenna, because we're not properly matched yet. So I'm pressing the push to talk, and you can see that I have some forward power but also some reflected power. So what I now have to do is adjust the controls of the antenna matching unit to reduce the reflected power to 0. So I'm looking for the needle to go down, so I've got it as far as I can on that one, I adjust this one, and I now have the needle of the reflected power meter at 0 and the full power reading 5 watts, which I've set the transmitter output to. So what this means is that the transmitter is now working into 50 ohms. The antenna impedance, whatever figure that might be, high resistance, low resistance, capacitive or inductance, has not changed. Downstream of the ATU, the antenna impedance is what it always was, but as far as the transmitter is concerned, it's working into 50 ohms resistive, which is what it is designed to do. Okay, just to sum up about matching the antenna, always choose a frequency that is clear. Make sure you're not going to be doing it and interfering with somebody else. Always do it at the lowest power output setting of your transmitter, and when you get your own radio equipment, what you want to do is find some spot frequencies at the various amateur bands and make a note of the settings of the antenna matching unit, and you can write them down on a sheet of paper so that as you change bands you can very rapidly get very close to a perfect match, and then it's just a little bit of tweaking of the antenna matching unit. One of the things you shouldn't do is change the inductor settings, click round on a switch when you're operating, as this can cause arcing of the contacts and you'll burn out the switch quite quickly, perhaps even at low frequency, at low power level. Okay, the next thing we're going to do is to set the microphone gain. You need to have sufficient drive from the microphone to modulate the RF carrier in lower sideband or upper sideband. Without any microphone gain, there is no output from the transmitter when you speak. You have to set the microphone gain to a sufficient level where it modulates the RF carrier initially and is not over modulating it so you distort. And we do this by adjusting the microphone gain control. I'm going to start with the microphone gain control at 0, and you will see that when I press the push to talk, there is no output from the transmitter. As I continue talking, I will rotate the microphone gain, and you will see that the output from the transmitter will come up, but it won't just keep rising and rising and rising. It'll get to a level and it'll stay at that level. That is the level you want to set the microphone gain to, or you can also turn it back a slight amount. Over-modulation will give you a horrible signal which can be a bit splatty and extend beyond the frequency that you're transmitting on. So I'll start by just pressing the push to talk. You'll see that there is no output, and as I carry on talking and rotating the microphone gain, probably round about the 11 o'clock position, that will be the ideal place to leave it. So I'm pressing the push to talk, and you can see there is no output. I now continue to talk. I rotate the microphone gain, and you can see now that I'm getting some output. I'm up at about the 11 o'clock position. Rotating it beyond there doesn't change the amount of output, so I come back to the 11 o'clock position, and that's my microphone gain set for my voice, and I shouldn't need to change that when I change frequency onto other bands. When you're doing setting the microphone gain, it's a good idea not to do this on air if you can. So we use something called a dummy load, which is just a 50 ohm resistor, but it has a 259 plug on the end, and you can plug that into the back of your transmitter, or in the case that we just did, there is a dummy load inside the ATU. The dummy load means that you don't transmit. It's a purely resistive load, and it means that you can set the microphone gain very accurately without interfering with other people by the fact that you're transmitting your test over the air. I'm now going to put out a CQ call on 80 meters. and CQ just means an invitation to all stations that anyone who hears my call can come back and have a QSO or a chat. I've matched the antenna to the transmitter for this particular frequency, so the transmitter is seeing a nice 50 ohm match load. What I do is I've found a quiet spot on the 80 meter band at 3.755 megahertz, and I've listened for 5 or 10 seconds just to make sure it really is quiet, and the first thing I'm going to do is to ask if the frequency is in use. Is this frequency in use, please? I do this because sometimes you can only hear half of a conversation because of the propagation, so there might be a conversation going on and I'm in the bit that I'm not hearing. If someone comes back and says, yes it is, I just say sorry and I move off somewhere else and start again. This sounds alright. Is this frequency busy, please? I just check one more time just to make absolutely sure. Sounds okay? Nothing heard. CQ, CQ, CQ. CQ 80, CQ 80 meters. This is Mike 0 Delta Charlie Victor. Mike 0 Delta Charlie Victor. CQ 80, CQ 80, CQ 80. CQ 80 meters from Mike 0 Delta Charlie Victor. Listening, standing by.
Mike 0 Delta Charlie Victor, this is 2 Echo 0 Whiskey Delta November. 2 Echo 0 Whiskey Delta November.
2 Echo 0 Whiskey Delta November, Mike 0 Delta Charlie Victor. Very good morning and thank you for coming back to the call. The name here is Peter, Papa Echo Tango Echo Romeo, Peter. The QTH is Foxton and we're about 12 kilometres southwest of Cambridge, and I'll give you a signal report on the next over. 2 Echo 0 Whiskey Delta November, Mike 0 Delta Charlie Victor, over.
Mike 0 DCB from 2 Echo 0 Whiskey Delta November, receiving you a good 559, and that's not surprising as I'm only a couple of villages away in a village called Watt. So receiving you 5, my name is Sierra Tango Echo Victor Echo, Steve, Sierra Tango Echo Victor Echo, and over to you.
2 Echo 0 Whiskey Delta November, M0 DCV. Yeah, good morning Steve. I've got a feeling from your call sign we've probably worked before because your voice sounds very familiar. You're a lovely signal here, you're a very good 5 and 7, so I imagine you're running fairly low power, and of course 80 metres this time of day can be a bit iffy, and we're probably on ground wave, but there you go. I've got Mike 0 India Papa Oscar in the shack with me, and we're just making a short video to help the people on the foundation course who are doing their theory by Zoom and who will be taking the exam via the remote invigilation. So it's just to add an air of verisimilitude to an otherwise bald narrative. 2 Echo 0 Whiskey Delta November from Mike 0 Delta Charlie Victor. Back to you, Steve.
Mike 0 DCB from 2 Echo 0 Whiskey Delta November. Yes, it doesn't seem long, but it's almost 2 years since I was on that very same course, and appreciated your teaching. Yes, I'm on 30 watts on an inside long wire, positive resonance, but it does seem to work quite well. And 30 watts is probably a bit overly generous for this distance, at least to make sure you can hear me. Back to you with any further comments. Over.
Yes indeed Steve, we're just running 10 watts here into an inverted V dipole fed with 300 ohm feeder. Anyway, thank you so much for the contact and coming back for the call. Nice to work you again and look forward to catching you sometime in the future. This is Mike 0 Delta Charlie Victor, now clear with 2 Echo 0 Whiskey Delta November, and just listening for your final. Back to you.
M0 DCV from 2 Echo 0 Whiskey Delta November. Fine, nice to be of assistance, and hope the course goes well. Bye.
Yeah, 73, Steve. We're now going to have a look at some of the other controls on the radio. In particular, one called the Receiver Independent Tuning Control, or RITI as it's sometimes called, or in this case it's called the clarifier. You use the receiver independent tuning if, when you've made a contact with someone and they come back and they sound slightly off frequency. Now the problem is, if you adjust your transmitter frequency on your transceiver so that they sound normal, if you will, the next time you transmit, you're transmitting on a slightly different frequency because you've adjusted this one to make it sound normal. The net effect of that is that they at their end will suddenly find that you sound a bit peculiar, so they will adjust their transmit frequency to try and make you sound the same. And the consequence is you're leapfrogging each other up the band. So what you have is this thing called the clarifier, or the receiver independent tuning, so that you can adjust the receive frequency. So I've now adjusted the receive frequency, but when I press my transmit, I transmit on my original frequency. So that way you can make both ends sound the same without leapfrogging up the bands over each other. The next control we're going to look at is the audio frequency control, sometimes called the volume control, which I'm sure you're familiar with. Very often you'll find signals are easier to hear at lower volume than at higher volume, and just adjusting it to get it to a comfortable level. Certainly if you're wearing headphones, always turn the audio frequency control right down and then bring it up slowly so that you don't give your ears a shock and end up going deaf after 5 or 6 years of abuse of high level of audio during your amateur radio operations. The radio frequency gain control, RF gain, I suppose you could say makes the radio more or less sensitive to the incoming signal. This is the RF gain control. At the moment I've got it fully counterclockwise, and you can see that we've got something like S5 of noise. As I reduce the RF gain, you can hear the noise disappear, but on the S meter it goes full scale that way. That's quite normal, and very often reducing the RF gain will also reduce the noise to a point where it's easier to copy the signal. So don't always operate with the RF gain fully clockwise thinking I'm going to hear everything, because it amplifies the noise as well. Set it back to somewhere that's comfortable, and you'll be able to resolve low level signals possibly a little easier.